Hello, my name is Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be working on Unit 5, Lesson number 2 on arithmetic and geometric sequences. Now, you studied both arithmetic and geometric sequences in Common Core Algebra 1, so you've had a little bit of work with them. Again, we're going to take that into account, but at the same time, we're also going to treat this topic as if it were virtually brand new. So, because again, think about it, 2 years ago, that was a while. So let's jump right into it and learn what an arithmetic sequence is. All right, arithmetic sequences. Well, let's take a look at the recursive definition. To have an arithmetic sequence, you have to be given the first term, f of 1, right? That's all that is. The first term. Never get confused by that, the first term. And then every term will be calculated by taking the previous term and adding some constant number, all right? Or we can look at it in subscript notation, the first term, every term, previous term, plus that constant. D is called the common difference. Now, we typically think about difference as a subtraction. And in fact, it is, because if you take just, let's say, this one, this definition, f of n equals f of n minus 1 plus d, and you move this to the other side by subtraction, what you see, or what I hope you'll see if I can write properly, is that f of n minus f of n minus 1 is equal to that constant difference. In other words, if you had a sequence like 3, 8, 13, 18, 23, etc. If you took any pair, like 18, and you subtract 13, you'd get 5. Or if you took this pair, 8 minus 3, you'd get 5. Or if you took this pair, 13 minus 8, you'd get 5. Right? It's what's called the common difference. Most students think of it as, all right, what you add on to get the next term. And that's absolutely the way you should think about it. But you can also think about it as if you subtract two consecutive terms. You'll also get that number. All right? So, let me clear this out, and let's get some practice. Exercise number 1 says to generate the next 3 terms of the given arithmetic sequences. So let's interpret this thing. Letter A, f of n equals f of n minus 1 plus 6. In other words, each term we're going to get by taking the previous term and adding 6. That's going to be easy. We have to do what? The next 3 terms? So f of 2 is simply going to be f of 1 plus 6. That's going to be 2 plus 6, so that's going to be 8. F of 3 is going to be f of 2 plus 6, and that's going to be 8 plus 6, and that's going to be 14. And f of 4 is going to be f of 3 plus 6, that's going to be 14 plus 6, and that's going to be 20, right? And again, you can see that common difference, right? If you do 14 minus 8, you get 6. If you do 20 minus 14, you get 6. A common difference, all right? Letter B is really no harder. We just threw some subscripts in there instead, but again, it's the same idea. Every term will be calculated by taking the previous term and adding 1/2. So a little fraction work for you, but whatever. A2 will be A1 plus 1/2. This is, after all, Common Core Algebra 2. It's not 5th grade math. 3/2 plus 1/2 is 4/2, which gives us 2. A3 will be A2 plus 1/2. Will be 2 plus 1/2, which is 2.5, 2.5, or 5/2, just getting it ready for the next one. A4 will be A3 plus 1/2, which will be 5/2 plus 1/2, 6/2, or 3. Now, by the way, that common difference can be positive or negative. In this particular example, both common differences were positive. In other words, the thing that we added on made the sequence get larger as the terms went on. But we could easily add on a negative, which would make the sequence go down, or if you will, it would force us to subtract to get each term. Okay? So, process this, pause the video, Write down what you need to, and then we're moving on. Okay, here we go. For some number t, the first three terms of an arithmetic sequence are 2t, 5t minus 1, and 6t plus 2. What is the numerical value of the fourth term? Hint, set up an equation that will solve for t. Wow. So all I know is that 2t, 5t minus 1, and 6t plus 2 forms an arithmetic sequence. And I want to know what the fourth term is. The numerical value, like is it 7, is it 18? It says first set up an equation that will solve for t. Well, before we do this, let me grab a value of t. Let me take t equals 1 and plug it in here. What would I have? I'd have 2. 5 minus 1 would be 4. 6, 7, 8, 8. Right? That's what I'd have if I put t equals 1 in there. Well, this isn't arithmetic, right? Because 4 minus 2 is 2, but 8 minus 4 is 4. So this is not a common difference. Not a common difference. So t equals 1 is not the right value of t to make it an arithmetic sequence. What I'd like you to do is pause this video and play around with this problem. Okay, obviously I know how to do it algebraically, but I'd like you to play around with it. It's a very common core-like problem. So take your time, pause the video. All right, let's go through it. You could definitely do some guess and check, play around with various values of t, but this is where you really have to know about common differences. You see, if I take the second term and I subtract off the first term, that's got to be equal to that common difference. Likewise, if I take the third term and I subtract off the second term, and I have to be very careful about that, that also has to be equal to d. But that means these two things must be equal to each other because it's a common difference. Right? It's a common difference. It isn't an uncommon difference. It's a common difference. They have to be equal. But now I can solve this equation. I'll have 3t minus 1 on the left. Here again, I have to be kind of careful because I have to distribute that negative. And I'll get 3t minus 1 equals 6t minus 5t is 1t. 2 plus 1 is 3. That's going to give me 2t on this side. Add the 1 to both sides, 4. And I get t equals 2. Well, what should I do with that? I'm looking for the fourth term. Let me take the 2 now and substitute it into here. Well, 2 times 2 is 4. 5 times 2 is 10, minus 1 is 9. 6 times 2 is 12, plus 2 is 14. Let's see if this is even reasonable. Let's see, 9 minus 4 is 5. 14 minus 9 is 5. Yeah, that's an arithmetic. And I just have to add another 5. So the fourth term is 19. That's a cool problem, isn't it? Forces you to set up a linear equation. Forces you to be careful with parentheses, distribute negatives. Right? And then you finally get your fourth term. But you really have to understand that idea of a common difference in order to set up the equation. All right, pause the video now and write down whatever you need to. All right, let's clear it out. And move it on. Exercise 3. Consider a sub n equals a sub n minus 1 plus 3, and a sub 1 equals 5. First part, determine the values of a2, a3, and a4. All right, go for it. You shouldn't need my help on this one. Okay, let's go through them. Well, this is definitely an arithmetic sequence. That common difference is 3. There it is, right? And it just says, hey, to figure out every term, I just take the previous one and add 3. So a2 is going to be a1 plus 3. That's 5 plus 3, and we get 8. A3 is going to be A2 plus 3, 5, oops, sorry, 8 plus 3, 11. And A4 is going to be A3 plus 3, which is 11 plus 3, and that's 14. Now, letter B is amazingly important. It says how many times was 3 added to 5 in order to produce A4? So, A1 was 5. And we added 3 here, and we added 3 here, and we added 3 here. So it was added only 3 times. To get to the fourth term, we added only 3 times. So what's the value of A of 50? I don't want to go through all of this. So what is the value of A of 50? Think about this. Well, to get from A1 to A50, what we're going to have to do is add 3 over and over and over again, and we're going to have to add it 49 times, not 50. Seems like it should be 50, but remember, for A4, we only added 3 times. So A sub 50 is going to be that starting value plus 49 additional 3's, right? Simple enough, and that gives us 152. Finally, we're going to come up with one of the most famous formulas, which is the formula that produces the nth term of an arithmetic sequence based on the first term, the common difference, and the number of terms. So do it. Think about what this formula would be. Go for it. All right, well, let's take a look at what we did last time. Right here, when we had n was 50, we took this thing, which was A1, and where'd that 49 came from? That came from the 50 minus 1, so we'll have n minus 1. And then what was that? That was that common difference. And there it is. A sub n is A sub 1 plus n minus 1 times the common difference. We take our first term and we add on 1 less than the position we are at line times the common difference. Famous formula. All right, pause the video now and write down anything you need to. All right, we're going to clear out the text. Backside of the sheet. Once we turn the page, that is. Exercise 4. Given A1 is 6 and A4 is 18, are members of an arithmetic sequence. Determine the value of A of 20. Now, this is a real nice Common Core problem because it's not just plug and chug. You really have to think about it a little bit. So spend some time and think about how you can figure out A of 20 and what you really need to figure out A of 20. So go for it. All right, well, I sincerely hope you took your time and you worked on this, because this is tricky. But let's think about this for a minute. We got this list, all right, and this is what I know. And eventually, right, we have our first term, our second term, our third term, our fourth term, and eventually I want the 20th term. Now, what's tricky is that we really want to know that common difference, right? This is the most important thing. What am I adding? But to get from the first term to the fourth term, right, we must have added that common difference 3 times, right? That allows us to solve for it. Whatever we added 3 times, once to get to 2, once to get to 3, and once to get to 4. So we can solve this. 3d is equal to 12, and the common difference must be 4. And you can kind of check that, right? You do 6 plus 4, you'll get 10. 10 plus 4, you'll get 14. 14 plus 4, you'll get 18. So this is my second, my third, and my fourth. But that's all we need now, because A20 is going to be A1 plus 19 of those d's, a1 being 6, d being 4. We can work all that out, and we find that our 20th term is 82. All right. Pause the video, take a look at what we have, and write down anything you need to. All right, let's clear it out. Now, we're going to shift our focus now to geometric sequences, and we're not going to spend as much time on them right now, because quite frankly, everything we did with arithmetic, we can also do with geometric. But let's figure out what a geometric sequence is. All right, a geometric sequence is defined very similar to an arithmetic sequence with one huge difference, right? You're given your first term, but then each term is simply the previous term times some number instead of having a number added. That number that we multiply by is called the common ratio. Now again, I want to explain where that name comes from, right? We know what ratios are. Ratio is just another kind of fancy word for fraction, if you will, right? So 2/3 is a ratio, 7/2 is a ratio. Well, what this is really saying is if we divided both sides by n minus 1, right, then what we see is that when we divide two consecutive terms, we will always get the same number. Always get the same number. So for instance, let's say we had 2, 6, 18, 54. I had to think about it a little bit. This is a geometric sequence because if we take, let's say, this and this, and we divide them, we get a common ratio, or we get a ratio of 3. If we take these two and we divide them, we get a ratio of 3. If we take these two and we divide them, we get a ratio of 3. All right, it's a geometric sequence. And yeah, that ratio tells you what you're going to multiply by each time to get the next element in the sequence. All right, let me erase this, then let's do some problems involving geometric sequences. All right, exercise 5. Generate the next 3 terms of the geometric sequence given below. All right, great. No problem, right? A2 is going to be A1 times R. So that's 4 times 2 gives me 8. That's A2. A3 is going to be A2 times R. So 8 times 2, so A3 is 16. A4 is A3 times R, which is 16 times 2, and A4 is 32. All right, simple enough, right? 4, 8, 16, 32. There is nothing that says the ratio has to be greater than 1. Now, if the ratio is less than 1, then what's happening, assuming it's positive, is that the values of our sequential terms are going down. So here we're going to generate each term by taking the previous term and multiplying by 1/3. So f of 2 is going to be f of 1 times 1/3. 9 times 1/3 equals 3. F of 3 is going to be f of 2 times 1/3. 3 times 1/3 equals 1. F of 4 is going to be f of 3 times 1/3. 1 times 1/3, which will be 1/3. Oh, and square roots. All right. This may require us to remember some things about square roots that are long buried in our head, but we'll give it a shot. Can't hurt. This one just says each term is produced by the previous term times root 2. So that means T2 is going to be 3 root 2 times root 2. The square root of 2 times the square root of 2 is just 2. So 3 times 2 is 6. So T2 is 6. T3 is T2 times root 2. Nothing special there. That's just going to be 6 times root 2. And I can't do anything with that. T4 is going to be T3 times root 2. 6 root 2 times root 2. Again, root 2 times root 2 is 2. 6 times 2 gives me 12. That's kind of a cool sequence. All right. So, I mean, generating, obviously, the values of either an arithmetic sequence or a geometric sequence, especially when they're defined recursively, is very easy. All right, so we're going to do one last exercise, and just like before, we're going to try to generate a formula that would allow us to figure out the value of any term in a geometric sequence, given that we know the first term and we know the common ratio. All right, pause the video now, though, and write down anything you need to. Okay, clearing it out. All right, here we go. Consider a1 equals 2 and a sub n equals a sub n minus 1 times 3. Letter A, generate the value of a sub 4. Go for it. This should be easy. All right. So we got a1, and it's equal to 2. a2 will be 2 times 3, or 6. a3 will be 6 times 3, or 18. And a4 will be 18 times 3, and that will be 54. Now there's my answer. But more importantly is letter B. How many times did you need to multiply 2 by 3 in order to find a4? Well, I did it here, here, and here. So 3 times. And just like before, that's one less than you might first think. To get to a4, we only have to multiply by our common ratio 3 times. So a10, right, will be 2 times 3, not to the 10th, but to the 9th. Now, regardless, that is a large number. It's 39,366. Geometric sequences where r is greater than 1 tend to grow very large very fast. So the last thing that we want, and this is a really important formula for future lessons, is we want a formula that will calculate a sub n, the nth term of any geometric sequence, given that we know the first term, the common ratio, and how many terms we have. So go for it. All right, well, let's just generalize from the one that we did in letter C. Before we had a10. Here we have a sub n. The 2 was a sub 1. The 3 was r. And then we have to always raise it to one less power. Right? We multiply it one less time than our index. All right, that's it. Pause the video now, write down anything you need to, and then we'll clear the text and wrap up the lesson. Okay, here we go. All right, well, that was a pretty brief review of arithmetic and geometric sequences, which you have seen before in other courses. Arithmetic sequences defined by a common difference. When we subtract any two consecutive terms, we always get the same number. In other words, we generate the sequence by adding the same thing each time. Geometric sequences, on the other hand, are produced by multiplying by the same number each time. Now, critical to both of these two types of sequences is how we figure out the nth term, given that we know the first term and then the common difference or the common ratio. Make sure to really take a look at those formulas and become comfortable with them, because we'll need them for future lessons. All right, for now though, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.